Assalamualaikum and good day to all. Today we're going to continue new chapter, which is virtual work method, in order to determine our statically indeterminate trusses. The course outcome is we able to analyze any trusses in order to determine the internal forces and displacement. Here's some of the type of different trusses around the globe we can see. In here you can see some of it. However, how do we know our truss is statically indeterminate? In order to do that, you have to remember this formula, which is M plus R equal to J, which is M is the total number of truss member, J is total number of joint, and R is number of reaction, and normally equal to 3 for R into the structure. If we find out the value of MR less than 2J, our truss is unstable and will collapse under load. However, if our M plus R more than 2J, that is statically indeterminate. That means the truss has more unknown than no equation. And then we have M plus R equal to J, which is statically determinate. Some of the structure are built with more than minimum number of truss member. Therefore, that structure may survive even some of the member are failed. This called statically indeterminate structure because their member force depend on the relative stiffness of the members. Now let's identify for this simple truss, and always do remember this formula: M plus R equal to J. M is members, number of member, R is reaction, J is joint. Now for A, number of member 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then reaction. From this, we know we have roller and we have pin. So 1, 2, 3. So our R is 3. Then our J, number of joint 1, 2, 3, 4, 5, 6, 7, 8. So we check our M plus R equal to 12 plus 3 is 15. Then we check our 2J is 2 times 8 equal to 16. Therefore, 15 less than 16. That means unstable. Now let's do the second one. Find numbers of members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So M equal to 15. Number of reaction, this is pin, we have X and Y reaction. This roller, we just have Y reaction. So our R is 3. Our joint number 1, 2, 3, 4, 5, 6, 7, 8. So our J is 8. Now let's find value for M plus R. 15 plus 3. Then value for 2J, 2 times 8 equal to 16. Therefore, This one is 18. 18 more than 16. Therefore, indeterminate. Alright, for the third one and fourth one, please try to find determinate or indeterminate. For the statically indeterminate truss, we can have externally indeterminate or EI, or we can have internally indeterminate, which is II. For the externally indeterminate, that means our truss have redundant reaction. Now let's take this truss for an example. Always remember, we have to check the external redundant first. From this reaction, we know we have pin, which is reaction X and Y. This one is roller. This one is roller. That means total reaction is 4. R equal to 4. EI equal to small r minus capital R. Normally, the capital R equal to 3. 4 minus 3 equal to 1. Thus, we have one redundant reaction. Therefore, we can take out this support easily. Next, let's do for internally indeterminate. Our II equal to M plus R minus 2J. Our reaction X, Y, Y. So our R equal to 3. Then we have to count how many members do we have for this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And how many joints do we have for this one? So our J, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So calculate value M plus R minus 2J. M is 22, R is 3, 2J, 2 times 12 equal to 1. Therefore, we have one redundant members. So we check the external. R minus 3 equal to 3 minus 3 equal to 0. Therefore, okay for externally. But do remember, in some cases, for our truss can have both externally and internally indeterminate truss, which is have redundant reaction and also redundant members. Alright, for your own exercise, try to determine the trusses below. Either is internally indeterminate, externally indeterminate, or both internally or externally indeterminate. Now we're going